Well, friends. It's looking so awesome. Tonight, as you can see, what we're gonna do is we're gonna talk about a party of logarithm sort of equations. As you can see, this is what we're gonna do today. Yeah, we're gonna do more logarithm. So a lot of questions. Yeah, about logarithm. Okay, so that's what we're gonna do tonight. All right. So let's see. We set the ball rolling. Okay, that's what we are. Beautiful. So it's sounding nice. So tonight we have a pool of logarithm equations that we want to have a look at. But I want you to take a cup of tea, just sit beside me, and we just set the ball rolling. Our first question we have is given as log base 4 into bracket 2x plus 7 equals to 2. Friends, just look at this question. It's very interesting, is it? We have been asked to find the value of x. Find x. So that's what we're looking for. Well, for this question, as we look at it, you see that it's just only 2 steps. Okay, so let's unwrap it. So now log to base 4 into bracket 2x plus 7 equals to 2. Okay, it's equals to 2. So what do? We can see that here, we can, if you remember, if we have log, if we have log a to p is equals to t, you remember that this same log can be written as p is equals to a raised to the power t. You see, this is one of the properties we learned earlier, as you can see. So we are going to apply the same to our proposed question. So now look at it. Applying this principle, then we can confidently say that log to the base 4 2x plus 7 equals to 2 can be written as 2x plus 7 is equal to 4 raised to the power 2. Having said it, we have applied the same principles that we learned earlier. So straight on, we can see that a 4 squared will be equal to 16. Have you seen that? When we square 4, we get 16. Then we subtract 2x from both sides of the equation. So we have 2x plus 7 equals to 16. Okay, so we are going to subtract 2x from both sides of the equation. So we have 2x minus that and minus 2x. You see? So this one will give a 0, okay, plus 7, okay. Yeah, no, when we take 7 out of the equation rather, and so it will be easier for us. So we'll do away with this. Okay, so we'll come here and we'll say subtract 7 from both sides of the equation. Okay, so we'll subtract 7. So our 7 here will be plus minus 7 minus 7 from both sides. So then we'll be left with So we're left with 2 is this would take care of that, and this one will take care of that, so that our equation will become 2x is equal to 16 minus 7, and that will give us 9. Okay, so this implies that our answer to this question will be 9/2. Okay, that's beautiful. It's so simple as that. So as you can see, all what we did was, applying the principles, some of the principles of logarithm that we learned earlier. And so by so doing, we changed the equation, the completion of the equation. So you see the 4, which is what we have over here, is moved under the 2 to become 4 to the power 2. And after that, the rest becomes simple algebra. Okay, now let's look at equation number 2. Equation number 2. Okay, equation number 2. Equation number 2 is another interesting one. It's a natural log of square root 5x minus 4 is equals to 3. And we should find the value of x. Friends, such a question is also another interesting one. You see that there's a natural log of this 5x minus 4 is equals to 3. We should find x again. Over here, bear in mind that anytime we see log, natural log of, for instance, of t can also be written as log to the base e of t. You see, that's a natural log of t. So because of that, the whole equation will change in the completion. Okay, to make it easier for us, we say this equation can be written as log to the base e, okay, into bracket 5x minus 4 is equals to 3. Okay, now this equation changes in completion once again. So you see that this, as we applied what we applied earlier, over here we are going to get our equation 5x minus 4 to be equals to e raised to the power 3. Okay, if we want to get rid of the log, okay, so once again we will say that 5x is equals to 4 plus e is the power 3. So dividing both sides by 5, our equation f will give us 1/5 into bracket 4 plus e raised to the power 3. This will be our final result. Now let's look at other equation once again that were given. The third one says natural log of s cubed is equals to 8. We should find the value of that. Natural log of s cubed. Alright, so the natural log of s cubed. So let's see, let's write it well. The s cubed, okay, so that's how it's supposed to be. So that's what we've been given. So let's see how we go about that. Bear in mind once again that natural log can also be written as log to the base e. Okay, so because of that, once again, okay, our equation will take on different look. So this one will be log to the base e of s cubed is equals to 8. You see, we know that this can be written as s cubed is equals to what? E, okay, raised to the power 8. So how do we find our x? Our x will be cube root of e raised to the power 8. Okay, this is the value of x. Well, it's looking very interesting that we have a pool of logarithm that is making the day very interesting. Let's tackle our next one once again. As you can see over here, question 4. Question 4 says we have log to base 5 and 8x minus 7, okay, is equals to log to the base 5 2x plus 13. You see, this equation is very interesting. It looks very long, but you know, if you look at it very carefully, you see that it becomes so easy since we have the same base. As you can see, the bases are the same. You see, we have a base 5 here and a base 5 here. So what I want us to do is, you know, pull the log to the base 5 2x plus 13 into the equation. So that when we do that, we are going to say log to the base 5 8x minus 7 minus log to the base 5 2x plus 13 is equal to 0. Have you seen it? This is equal to 0. That has made the equation so easy. Well, please, if you look at it, as I said earlier, the bases are the same. So what do? This, since we see logarithm over here, we have to remember some of the properties that we've learned over the months that we've been working together. Remember that if we have a log, okay, a to b minus log a to, let's say, c, we can say that it's log a to b divided by log a to c. Have you seen that? So if we are going to apply what we've written over here, then our equation is going to be so easy for us since they are subtracting. Okay, let's go back and see. So if we apply this, you see, to this question, then we can say that this equation will be log base 5 into bracket 8x minus 7 all over log to the base 5 2x plus 13 is equal to 0. Okay, then this can be simplified as log to the base 5 into bracket 8x minus 7 all over 2x plus 13 is equal to 0. Have you seen that? Now, since this base is 5 over here, when we get rid of that, we are going to apply one more principle as we saw earlier. That principle of logarithm, or the rule of logarithm, that's if you have log to the base a of b is equal to t. You say this is the same as saying that b is equal to a raised to the power t. Remember, so this is another logarithm principles or rules. Okay, so if we are going to apply that one, then in a simple sense, our equation will be 8x minus 7 all over 2x plus 13 is equal to 5 raised to the power 0. Friends, we know for sure that 5 raised to the power 0 will always be equal to 1. If that is the case, then our equation 8x minus 7 all over 2x plus 13 will be equal to 1. Okay, you see 1 is divisible by 1. As the time immemorial, 1 is always divisible by 1. So after that, what we do is we say cross multiple or cross multiplying. So when we say cross multiplying, that means this one is going to multiply this, and this one is going to multiply that. Have you seen that? So beautifully, when we do cross multiple, we are going to get 8x minus 7 to be equal to 2x plus 13. Okay, so this becomes a very simple equation to solve. So let's group the like terms. We see that in equation, as we said earlier, whatever you do to the left, you do the same to the right. So when I move 2x from both sides, I'm going to get 8x minus 2x. Yeah? And over here, I'm going to get 13 plus 7. You see, so I've grouped the like terms. What I did to the 7 was I added 7 to both sides. Okay? So now, we see that 8 minus 2x will give us 6x. Friends? And 13 plus 7 will be 20. So dividing both sides by x, okay, our equation will be 20 divided by 6, which is the same as 10 over 3. So hence, equation is solved. We have 10 over 3 to be our answer to this equation. Okay, so as you can see, that's what we did. The whole equation was very, very long as we saw it. Okay, that's how it was given. And we saw that the equation have the same base. So we pulled the right hand side variables back into the equation. Then we reminded ourselves for this equation. Okay, for this equation over here is some of the properties of logarithm. As you can see here, you see, so having this property in mind, that makes the equation so easy for us to solve. Have you seen that? So it's a log to the base a to b minus log to the base a to c. So on the right hand side become log to the base a to b dividing log to the base a to c. So applying the same to our equation. So this is how equation becomes. Okay, you see, now we will have log to the base 5. Okay, and 8 minus 7 is divided by that. It's equals to what? 0. Have you seen that? Now, when we also employ this property that we learned earlier in logarithm, now it says log to the base a to b okay, is equals to a t of a certain variable. And we were told that if you look at it from the right hand side, b will be there as a certain number, and a being the base will be raised to power t. So we did the same thing and we applied to this, and we know that 5, yes, go to the right hand side and raise the power 0. But we know any number raised to the power 0 is 1. Okay, after that we did cross multiplying and we were able to find our answer. Isn't that beautiful, friends? Well, let's tackle one more question we have over here. Question number 5. Question number 5. Question number 5 is also for graph. So 5, we have log 2 the base 2 and x plus 5. Then log to the base 2 x plus 1, and it says equals to 5. Oh, beautiful. So log to the base. You see now, also this very question, the bases are the same. Have you seen it? Our base 2 here is the same as that. And there's an addition sign in between them that reminds us of this very property, again, of logarithm. That says if we have log to the base a of x plus log to the base of y, it says always equals to log to the base a xy. Have you seen that? So because of that, when we look at the left hand side of the equation, that says log to the base 2 x into bracket x plus 5 plus log to the base 2 into bracket x plus 1 is equals to 5. Applying this principle of logarithm to this equation will make life easier. So we said this, because of this, we are going to get log to the base a into bracket x plus 5 into bracket x plus 1 is equals to what? 5. Friends, we know this. Yeah? Our base given was 2. So when we put the 2 back there, this is what we have. So that all what we gotta do is to apply this principle. I will write it down again. Okay, that says log to the base b of t equals to, let's say, b. It says what? It can be written as t is equals to b raised to the power capital B. You get it? So if that is the case, when we are going to apply the same principle, then our equation is once again going to have a very different uniform. So this one is going to be x plus 5 into bracket x plus 1 into bracket is equal to 2 raised to the power 5. Have you seen it? 2 raised to the power 5. Right? 2 raised to the power 5, as we know. Yeah, we are going to get here. So let's break it down. So 2 raised to the power 5, that's a 2 times 2 times 2 times 2 times 2. So 2 of the 5. This 2 will give us 4, 4, and times 2. So 16 times 2. Okay. So what do we get? 5 of the 2 of the 5s. So 16 times 16, 2 times 2, 4, and this 4 times 4 is 16, 16 times 2. As you can see, 2 is 12. 1. So we have 32. So you see, our x plus 5 into bracket x plus 1 will be equal to 32. So what do? We have to do some kind of expansion. So we multiply, you see, so let me break it down again. So you see, this will multiply all this, and also we'll also multiply that. Okay. After that, okay, this will, after this multiply this and that, and this will multiply this and multiply this. As you can see, this is our simple way of doing binomial and then expansion, or yeah. So let's look at it. So the x is going to multiply x. So we are going to have x squared plus x. Okay, that is, see, this one that's multiplying this x squared. Let's multiply 1. So s squared plus x. Then we hit this one will be 5 multiplying x plus 5 multiply 1 is equal to 32. Okay, so you see, I'm trying as much as possible to break it down so everybody will be able to get it. So x plus 5x will give us 6x plus 5. Friends, it's becoming easier. So we have x squared, have you seen? X squared plus 6x plus 5. So when we bring our equation together, then we are going to get plus 5 minus 32 is equal to 0. Friends, it's becoming simple, isn't it? So now, when we look at it, we are going to get x squared plus 6x, okay, minus, okay, 27 is equal to 0. So you see that the complexion of our equation has changed. Look at the equation. So the equation is now quadratic. So we say as quadratic in x 27, okay, 29, 27. So our factors, as you can see, our coefficient of x squared is 1. So we multiply by negative 27, we have negative 27. So the factors of negative 27, that will give us positive 6, will be 9 times negative 3. You see, so you see, when I add this together, on addition, I'm going to get 6. So you see that this will be the factor. So that this, we say this implies that x squared plus 9x minus 3x minus 27 is equal to 0. You see, as quadratic. And so what do? We have to do factorization. Yeah, we do factorization. So when we factorize, we bring our x out, we see x plus 9, okay? And here we minus 3, x plus 9 again is equal to 0. You see, when you look at it, if you do your factorization very well, you're always going to have a common values that will repeat themselves. So you see here we have x plus 9 and x plus 9, which is very common to both factorization. Or so we can say we'll pick this and this one, and we'll pick this. So we say x minus 3 into bracket and x plus 9 is equal to 0. You see, so now we say x minus 3 is equal to 0, or x plus 9 is equal to 0, because they are multiplying. So this will imply that x is equal to 3, or x is equal to negative 9. This is our answer to this equation. So let's go back and have a glance at what we've done so far. So when we look at the equation, you see, what do we see? Log to the base 2x plus 5 plus log to the base 2x plus 1 is equal to 5. Then we reminded ourselves what this equations of logarithm. You see, we reminded ourselves with this. Okay, because this is the addition property of logarithm. You see, have you seen how it is? So we apply this principle. If you look at the right hand side, you see that will make the difference. But log to the base x plus log to the base y is similar to the equation given. Okay, so our concentration, okay, lied on the path of log to the base axy. So that is why instead of that, we say log to the base 2x plus 5 multiplying x plus 1 is equals to 5. Okay, after that, we also apply this one more principle that we see all the time when we're doing logarithm. Look at it. You see, this says log to the base b, okay, of a certain variable t or a number t is always equal to a certain number t, b. So this in its conversion form is to be t is equal to b raised to the power b. Smaller b raised to the power b. So that, if that is the case, then our log to the base 2 over there will vanish to go up there and carry the 5. So that is why we got this equation. Okay, so x plus 5 plus x1 plus 1 is equal to 2 raised to the power 5. And as we saw, 2 raised to the power 5 gives us 32. What did we do? We did expansion over here. So as we can see, the green ones multiplying the first bracket. Okay, when we pick the x, multiply the x and 1. And we pick the 5, multiply x and 1. And we have this equation. That's the x squared plus x plus 5x plus 5 equals 32. Okay, so we brought the 32 in here, and 5 minus 32 was negative 27. So x squared plus 6x minus 27. As you can see, well, you realize that say when we have equation of that form here, okay, then we say quadratic in x, because the variables are dominant over here is x. So what do? We found ourselves the factors. We realize it's negative 27. And the factors that will help us to get a 6 in between them is 9 and 3, negative 3. So 9 times negative 3 gives us negative 27. But when we add 9 and negative 3, we get 6. So we said our factors are 9x and minus 3x. So we substituted back into the equation. We have x squared plus 9x. You see, x squared plus 9x minus 3x, yes, minus 27 equals 0. Then we did a bit of factorization over here. We pull x out. Then we have x into bracket x plus 9 and minus 3 into bracket x plus 9 equals 0. Okay, so we then that helped us to pull the common ones aside. So we see that x minus 3, we have to put them together and x plus 9 being common. Alright, then we go to this point where we say x minus 3 and x plus 9 equals 0. Then we were able to find our answer. Well, friends, it's looking very interesting. Very, very, very interesting. Let's look at a question number 8. Let's look at question number 8. Question number 8 is also another interesting one. Let me have a look at it. What question was this? This one we did. Okay. So our next question, let's tackle it. The question says log, yeah, it says log, to the base 8, 16 plus log to the base 2 x is equal to 4 over 3. And we should solve the question. If you look at this, very interesting. If you look at 8 and 16, okay, it's very interesting because you see over here we have base 2. So that helped me to think of changing log 8 to 16 to something else. But let's see, log 8 to 16. I say let this is equal to p. Okay, so if that is the case, then we say 16 is equals to 8 raised to the power p, as we saw earlier from the principles of logarithm. All right, then we can say take log base 2 to both sides of equation 1, to take 2 to both sides, to log 2 to both sides of the equation. So here we will log to the base 2 of 16 is equals to log to the base 2 of 8p. What am I doing? I'm just trying to change the base to the same base. Well, I don't believe in memorizing it, so we have to break it from the scratch. And we know for sure that here 2, when we say 4 times 4, we give us 16. So 2 times 2, 2 times 2. So 2 raised to the power 4 will give us 16. You see? So here we say log 2 raised to the power 4 is equal to 8 means log 2. Okay, and the p comes here. This will be 8. And we can also further break the 8. So we see log 2, okay, 2 raised to the power 4 is equals to p log 2 raised to the power 3. So this will be 4 log of 2 of 2, okay, which is equals to 2p log of 2 base 2. What do you see? We know that we say but log 2 base 2 will give us 1. You see, friends? So our left hand side will be 4 equals to 2p, and so therefore this implies that p here equals to 2. So that will be 4 over 2. Our answer will be 2. So that one, all this long thing we saw over here that says log 8 to 16 will be 2. So now this implies our 2 plus log 2x is equal to 4 over 3. Friends, have you seen it? Yeah? So how do we solve it? It's now easy. So we say that here, subtracting both 2 from both sides, we are going to get log 2x to be equal to 4 over 3 minus 2. Okay? Now, this we can say log 2x is equals to 4 over 3 minus 6 over 3, okay, which is equals to negative 2 over 3, okay, that's when we subtract. So log 2x, which is equals to negative 2 over 3, our answer for x will be 2 raised to the power negative 2 over 3. Have you seen it? As simple as that. Friends, I think that's where we'll finish for today. Alright? Until we meet again, please subscribe and also ring or click the bell so you'll be the first person to be prompted for our next tutorial. You have a lovely day and enjoy. Bye.